Hello everyone and welcome to the OpenGL 3D game tutorial series, a new tutorial series in which we will build a 3D game in C++ and OpenGL from scratch. In this first episode, we'll see how to create the window in which we will draw the 3D objects that will compose our game world. In each episode of this series, we will face three main parts: the requirements, design, and implementation of our 3D game. Let's start with the requirements. We need a C++ IDE. In this series we will use Visual Studio 2019 Community, but any other C++ IDE could go well. However, Visual Studio is strongly recommended. The target platforms are Windows initially, macOS and Linux later. The target graphics API is OpenGL. And last but not least, a bit of knowledge of C++ programming language is recommended. Now we can start the design part, in which we will decide what classes to implement and how to organize them. To face this part, we could start to answer a question. What's the problem to solve? We want to create a window in which to render our 3D game, so we have just found a class very quickly, that is the window. But is only window class enough? Well, what we need is a further class that manages the window itself and other components of our game, like the OpenGL Engine, in particular its initialization and release, and so on. Let's call this class Game. Also, the game class should provide a very important function called run, in which a while loop, commonly called game loop, maintains our game in execution until the window is not closed. If you have questions, doubts, or comments about this topic, don't hesitate to leave them in the comment section of this video or in the Discord server. The link to the Discord server is available in the video description. Also, if you find these tutorials helpful, please consider to support their development on Patreon. Every single contribution makes the difference, regardless the amount. Very well, we have gathered all the necessary information to start the implementation. As first thing, let's open Visual Studio 2019 Community. Then let's click on Create a new project. Here, let's select the empty project template. Let's click on Next button. At this point, we have to choose a project name. Let's choose OpenGL Game. Obviously, you can choose your preferred one. Then we have to choose the project location. Let's go ahead and make sure the option Place Solution and Project in the same directory is selected. Very well, we can finally create our project. Now, the first thing to do is to enable the option Show All Files. This feature allows us to organize the folders and source code files directly from the Solution Explorer. Then, let's make sure that the solution platform selected is x64 in such a way to support 64-bit platforms. Very well, let's make our first folder and let's call it Game. In this folder we will place all the source code files about, obviously, the game. Then let's add the main C++ file. In this file we can finally add our first lines of code. Let's write the famous main function. Obviously, we haven't added a lot of source code yet, but let's compile for the first time our game, so to say. And it works! It closes immediately as expected, but it works. Very well. Let's move on and let's finally create the engine folder. Let's call our engine with an abbreviation, OGL3D, that stands for OpenGL 3D. Good, at this point we have to create two folders, include, where we will place all the header files of our engine, and in general all the files of the engine we want to provide publicly to the user. And then we have the source folder, where instead we will place the C++ files and in general all the private source code files. Now let's add OGL3D folders in both include and source folders. We organize the folders in this way in order to handle them in an easy way. Good, at this point, in OGL3D folders just created, let's add window folders. We can finally create the window class. Let's call it OWindow. O at the beginning of the name indicates that the class belongs to the OGL3D engine. Let's move the header file in the subfolder of include and C++ file in the subfolder of source. At this point, we have to modify the include directive. In order to simplify the work, let's go to OpenGL game properties and in VC++ directories, let's modify the include directories field. Here, let's add the OGL3D/include folder and OGL3D/source folder. Good! Now we are able to find easily all the header files of our engine. Indeed, if now we want to include the OWindow header file here, we can find it at OGL3D/window/OWindow.h. Make sure to use the slashes and not the backslashes, in such a way to be aligned with the other operating systems like Mac OS and Linux. Very well, let's finally implement our window. Let's start by adding the constructor and destructor. Let's implement them easily by using the quick actions and refactoring feature of Visual Studio. We can finally create our window with Win32 API. As first thing, let's include the Windows header file, where all the Win32 functions are defined. Then in the constructor, let's create a variable WC of type WND class X. This type of object defines the properties of a specific class of Windows. Let's initialize it by using the braces in this way. This way to initialize the object is called list initialization, and it is available since C++11. By doing in this way, we are cleaning all the attributes of this object with null. This is very important, otherwise the creation of the window will fail. Good, at this point we have to use only 3 attributes: CB size, in which we have to pass the size of WND class X object, the class name, that is a string used by the operating system to identify this class of Windows, and in the end we have the WND proc. We will deepen this attribute in few moments. For now, let's pass the def window proc function. Perfect! In order to let the operating system know about this class, we have to register it. We can do this by using the register class X, where we have to pass the address of our WC variable. We can do this by using the AND operator. At this point, we have to find a way to handle the case in which register class X fails. We can do that by using the assert function. Assert function allows us to abort the program if the expression passed as parameter is false, providing also some useful information in the console program. This is a simple way to handle the errors. We will deepen this topic in the next tutorials. Now we can finally create the window by using the createWindowX function. As first parameter, we should pass the extended style. We don't care about that now, so let's pass null. Then we should pass the class name. Let's take the class name used previously. The third parameter requires the window title. Let's use the title we like the most. At this point, the function requires a list of window styles that define the visual aspect of our window. Now the function wants the position and size of our window. Since we don't want to give a fixed position to our window at the initialization, let's entrust this job to the operating system by using the CW useDefault value for both the X and Y parameters. Then we add the width and height properties. Let's set a width of 1024 pixels and a height of 768 pixels. This is not enough. This width and height corresponds to the entire window size, title bar and borders included. But we want to give that size only to the window content, also called client area. To do that, let's use the adjustWindowRect function. This function allows us to get the real window size passing the desired client area size. Very well, we can pass null to the last 4 parameters. At the end, createWindowX returns an handle to the window just created. We have to save it somewhere though. So let's add a new attribute into our window class and let's call it handle. The m underscore stands for member in order to identify easily this variable as member of the class. At this point, if the createWindowX fails, it returns null, so let's check it using again the assert function. In the end, let's show the window by using the showWindow and updateWindow functions. When the destructor is called, let's destroy our window by calling the destroyWindow function. We have finished to create our first window with Win32 API. Cool, it's the time to create the game class. So let's add a new folder in include and let's call it game. Let's do the same thing in source. Let's create a new class and let's call it OGame. As we have already done previously, let's move the files in their corresponding folders. Let's start by defining the constructor, destructor, and the run methods. We have to finally implement the run method. Here we have to place the game loop, that is a while loop that runs until a specific condition is met. In this case, we can use a special Boolean variable called isRunning that indicates, as the name suggests, if the game is currently running. Let's initialize it as true. Now let's place isRunning flag in the condition of the while loop. At this point, a question comes spontaneously. When will isRunning flag be settled as false? For this purpose, we can add a further method in game class called quit. Now, what do we have to do? We have to process the various messages generated by our window. A message is generated each time we do an operation on the window. For example, when we click the close button, move the window, resize the window, and so on. If we don't process these messages, we cannot do any of the operation just mentioned. So, to process these messages, we have to call a Win32 function called pickMessage. PickMessage, as the name suggests, checks a special message queue for a posted message. It wants a pointer to a message structure, the handle to the window whose messages are to be retrieved. In this case, we pass null in such a way to process all the messages of all the windows created by our game. Then we pass null to the third and fourth parameters, and as last thing, we pass pmRemove to the fifth parameter. This value allows to remove a message from the queue each time we call pickMessage. At this point, if there is a message in the queue, pickMessage returns true, and in that case, we use the translate message and dispatch message to translate and dispatch the message just retrieved to the window procedure of our window. We will see what is the window procedure in few moments. A last thing to do is to call sleep. This function allows to suspend the execution of our program for the specified time, in this case 1 millisecond. We do that in order to prevent useless iCPU usage. Good, at this point we have only to create the window in our game class. Let's add a window attribute. And let's create an instance of a window in game constructor. Make sure to delete it in the game destructor. Consider that this is an old way to handle the creation of an instance in C++, in particular in this case where we delete the instance during the destructor. We will see a better approach in few moments. In the end, let's create a no-gain instance in the main function. And let's call run. Very well, let's see if it works. And it works! The window is shown correctly and responds to our inputs. But if we close the window, the game doesn't terminate. This because we are not currently handling the events of our window. So how can we handle those events? With the previously mentioned window procedure. So let's go to our Windows C++ file and let's finally create the window procedure with the following signature. At this point, let's make a switch statement, in which we handle the message parameter. When we are in the default case, let's return the value of default window procedure function. Let's come back to the message parameter. This parameter contains the identifier of the event generated by our window. For now, we want to handle the destroy event of our window. This event is identified by WNDestroy. The problem now is how can we inform our window class about the destroying event? First, let's add an onDestroy method in window class. Then, in order to retrieve our window instance in the window procedure, we have to use the setWindowLongPointer function. This function allows us to store the OWindow instance pointer in a special data structure identified by the handle of the window. At this point, we can retrieve this pointer inside our window procedure by using the getWindowLongPointer function. And once we have retrieved our window instance, we can call the onDestroy method. Now, every time we will close the window, this method will be called. For this fact, in onDestroy method, let's reset the handle. Good! What's the next step to do? The next step is to close our game once the window is destroyed. One approach to handle this case is to add a method like isClosed into window class. in order to know if the window is closed or not. For this purpose, we can return directly the handle of the window. If the handle is null, then the window is closed. Let's go to our game C++ file, and here let's run our game loop until the isRunning flag is true and the window is not closed. Let's see if it works. And it works. A last thing to do is to instantiate and release our window inside game class with a different approach. Here we are using a row pointer. That is a simple pointer that contains the address to the instance of our window. In order to destroy this instance, we have to manually delete it with the delete function. But there is another approach based on the so-called smart pointers. In few words, a smart pointer, in particular the unique pointer we are going to use, is nothing more than an object that takes a pointer to a particular type of instance during its construction, in our case a pointer to a window instance. Then, when the destructor of this object is called, it deletes the pointer that manages. This kind of approach is really helpful to avoid memory leaks and so on. That's all for now, folks. Today we have seen how to create a window with Win32 API and how to create the game class. In the next episode, we will see how to make the OpenGL 3D engine. I hope you enjoyed this video. See you soon. Thanks for watching.